Midterm Contaminant PowerPoint Project on Mercury by Cheyenne Rosenbaum. The purpose of this presentation is to understand the environmental toxicological effect of the element mercury. This will be accomplished by discussing the introduction, uses, environmental guidelines, pathways of environmental impact, case study, and conclusion sections. Mercury can be found on the periodic table of elements within the transition metals section. Its atomic number is 80, which refers to how many protons it has, and its atomic mass is 200.59, which refers to how many protons and neutrons it has. Other elemental properties include a melting point of negative 38.87 degrees Celsius and a boiling point of 356.9 degrees Celsius, which are low for a metal, and a specific gravity of 13.5 at 20 degrees Celsius. These elemental properties contribute to why mercury is rather heavy for its volume and the only common liquid metal at room temperature. The known presence of mercury dates back to 15 BCE in Egypt. The chemical symbol of mercury is Hg because its Latin name is hydronium, which directly translates to liquid silver, which is why mercury is sometimes referred to as liquid silver. In nature, mercury can be found in its pure elemental liquid state, but usually it is found in its ore form. Mercury makes up 0.08 grams per ton of rock on the Earth's crust, and it is commonly found near hot springs and volcanoes in Chile, China, and Nevada. The mercury ore is generally mined as the red sulfate compound cinnabar. It can also be mined as the black sulfate version as well. Since it readily dissolves gold, it is generally a byproduct of gold mining. Mercury in the ocean currently reads at 290 million moles, which is more than 3 times higher than the 85.29 million moles recorded during the time of the Industrial Revolution. In the ocean, mercury has organic and inorganic forms. Later, we will discuss the organic forms, which are familiar to us because of its presence in the seafood industry. The United States Geological Survey Mineral Information Team explains that mercury in the United States has been favored against due to safer alternatives and technological advances. The classic example is the old mercury thermometers, where mercury would expand and travel up the thermometer as it is placed in something warm. These have been since replaced by alcohol-based thermometers. Mercury conducts electricity easily and is used to be used as a common electrical switch. Depending on how the tilt switch bulb is tilted, it would either touch the prongs and complete the circuit or not. Dental fillings consist of a mercury mixture or amalgam are deemed safe by the FDA and still common in the United States. The USGS states that there are 290 tons of mercury in the form of dental fillings in the United States mouths as of 2013. Other uses of mercury include the backing of vintage mirrors. An identifier of mercury mirrors consists of black age splotching, although tin and silver do this as well. The classic Mad Hatter usage, where hatters would commonly contract mercury poison from using an orange mercuric nitrate compound to soften hats. This process is known as carroting. And lastly, mercuric chloride was used as a common laxative in the medicine calomel. This insoluble salt is theoretically not absorbable by the body. It is still a controversial topic with evidence on both sides. However, the United States doesn't actively use this as a medicine. The Environmental Protection Agency breaks mercury legislation into 2 categories: mercury-specific laws and other environmental laws that limit mercury exposure. The mercury laws include the Mercury Export Ban of 2008, which it prohibits metallic mercury export after 2013, and Mercury Containing and Rechargeable Battery Management Act of 1996, which phased out mercury from rechargeable batteries. Other environmental laws include the Clean Air Act, the Clean Water Act, the Emergency Planning and Community Right to Know Act, the Resource Conservation and Recovery Act, and the Safe Drinking Water Act. These acts limit mercury in the water and air, along with making records available to the public. Pathways of the environment include, according to the New Hampshire Department of Environmental Services, there are two ways of mercury entering the environment: naturally and anthropocentrically. Naturally consists of two phases: introduction and reintroduction. Introduction happens via volcanic eruptions and the weathering of rocks and soils, and forest fires. Reintroduction can occur when water evaporates out of the ocean and leaves behind mercury compounds. Anthropological or human-introduced ways mercury enters the environment includes the burning of fossil fuels and municipal or medical waste. 50 to 75% of environmentally induced mercury is due to these human activities. This is an issue because once mercury is introduced into the environment, it generally stays in the environment. There are three key forms of mercury: elemental, inorganic, and organic. Elemental mercury is the liquid version that can be found in the previously mentioned tilt switch, thermometer, and dental amalgams. Inorganic mercury is the salt form, which can be found in products like calomel and skin lighteners. Lastly, organic mercury is what we are most familiar with in terms of harm to human health, such as heavy metal poisoning and neurological deterioration. Organic mercury can be found in the seafood markets such as shellfish and top predator fish. Elemental mercury isn't volatile in itself, but the vapors that it emits is extremely toxic when inhaled. Inorganic mercury salts are able to be passed through the body and out with the urine to some extent, whereas organic mercury has a much harder time leaving the body. This form is what affects human health on a societal level through bioaccumulation and biomagnification. Once mercury has entered the body, it is going to stay there. Bioaccumulation occurs within a single organism over a lifetime as it eats more contaminated foods. Biomagnification of methylmercury follows the energy that is passed up the food chain. Large predatory fish, like sharks and swordfish, have higher concentrations of mercury because they have to eat much small fish. This section will be discussing the case study published in 2007 on the relationship between wetlands and mercury and brook trout by Castro et al. Brook trout can be identified by green marbling on their backs, also known as vermiculation, with the red spot blue halo combo on their sides. The objective of this study was to determine if wetlands influenced mercury concentrations in brook trout, benthic macroinvertebrates in stream water. We will focus only on the influence in regard to brook trout. Following along with Table 1, this study on brook trout, which are scientifically called Salvelinus ventinalis, started in September 26, 2005 at wetlands on the Blue Lick Run, Monroe Run, Upper Savage River, and Little Savage River, which resides in the upper left panhandle section of Maryland. Fish were collected by electrofishing, bagging, put on ice, and then transported to a lab. At the lab, they were processed using the ultra-clean protocols, which seem to be the process of filleting, blending, and then blending them into a slurry, and then testing for mercury. The results show that brook trout with higher levels of mercury in blue have a correlation with the locations that have higher percentages of wetlands in red. In conclusion, mercury is a liquid metal at room temperature that used to have many medical and practical applications. However, it has been mainly phased out in the United States. In 2008, the EPA banned the export of mercury from the U.S., and many other environmental legislations address mercury in the U.S., such as the Clean Water Act. These legislations arose from the increase of mercury in the environment via anthropocentric means of burning fossil fuels and waste. The organic form of mercury is considered the most dangerous form of mercury because it builds up via bioaccumulation and biomagnification. Lastly, the case study on relationships between wetlands and mercury in brook trout was an example of this toxin in relation to the environment, which results in the correlation of increase of mercury in brook trout streams containing higher percentages of wetlands. These are my sources.